Now we're going to look at postulate 23, which is called the arc addition postulate. Now we've had many addition postulates. We've had segment addition, we've had angle addition, so of course it makes sense to have an arc addition postulate. And it states the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. So you can see here in this picture, at first they have the black, the measure of arc A, B, C is going to, of course, be the measure of arc AB and the measure of arc BC added up. And notice that they are adjacent to each other. So this is just going to be like any other addition postulate that we've studied. Two parts equals the whole. So let's look at an example. We've got number 2. It says you join a new bank and divide your money several ways as shown in the circle graph. Find the indicated arc measures. Now again, for some reason, my arc measures are not showing up. So these, of course, should have little arcs here. So let's take care of that first. And it says, find the indicated arc. So the first thing it tells us to do is to find arc BD. So the first thing, notice the notation, it's 2 letters. So I know I go minor arc. I do not go on the other side because it's got to be less than 180. So this is when we are going to use the arc addition. Since this angle is 55 degrees, that means this arc AB is 55 degrees. Since this arc is 105 degrees, or this angle is 105 degrees, this arc is 105 degrees. So we simply employ the arc addition postulate where we say 55 degrees plus 105 degrees equals 160 degrees. Keep in mind, this is a minor arc. It's less than 180. Now, moving on to the measure of BCD, so I'm going to clean the picture up. And now I'm going to find BCD. So now this must go BCD. So it's got to go the 3 letters, and they all have to be adjacent. So again, this angle is 140 degrees, therefore this arc is 140 degrees. This one is going to be 60 degrees. So we've got 2 adjacent arcs. So one way to do it could be 140 degrees plus 60 degrees for a total of 200. Now, I also want you to see that there is another way to do this. We just found in the previous problem this part. So we could have also done 360 degrees, subtract 160 degrees, and we'll still get 200 degrees. So you have some options in solving problems like this. Now part C, again, I'm going to clean up the picture so we can start new. On this next one, it is asking us to do BCA. So BC all the way back around to A. So I think for this one, instead of adding up these 3 arcs, it's just easiest to subtract 55 degrees from 360. So we're just going to go 360 degrees minus 55 degrees and get 305 degrees. Again, it is a major arc. It is more than 180 degrees, but less than 180. And now for the final problem, D, it says find the measure of ABC. So ABC. So ABC starts here and goes all the way around. So you can see here. So ABC. And I think the best thing to do here is just to take this 55 degrees and this 140 degrees and add those up. So 55 degrees plus 140 degrees is going to give me 195 degrees. So the arc addition postulate is just going to behave like all of the other ones. 2 parts, 3 parts make a whole. And with the circle, you can certainly subtract from 360 if that is quicker. Now moving on to the next part, the vocabulary for congruent circles and congruent arcs. So the first thing we need to look at is exactly what is a congruent circle, okay? So circles are congruent if they have the same radius. So if you look over here at this picture, I have circle with a radius here coming from A, and there's a tick mark on it. And over here is circle B, and there's a tick mark on it. Therefore, since they have the same radius, these circles are congruent. And this would be the notation. We would say circle A is congruent to circle B because they are congruent. Now, I need you also to know from the similarity, all circles are similar. So all circles are similar, but not all circles are congruent. Now, the next thing we need to examine is exactly what is a congruent arc. So a congruent arc is going to be, the arcs that are congruent, they're going to have the same measure, and there's a key word there, and are on the same circle or congruent circles. So sometimes this can be a little bit confusing to students, so I kind of want to give you a lot of options and just make you aware of what in the world the same circle and congruent circles means when it talks about congruent arcs. So I've gave you actually 4 examples here at the bottom, and it says tell whether the given arcs are congruent and then explain why or why not. So looking at number 3, again, my little arc measures are not there. I don't know what happened to those, so all of these are arcs, so let me add those in there. But number 3 says arc BC, which is here, and arc DE. Are those congruent arcs? Okay, so this case is going to be a yes. They are congruent, but there is a reason that we say yes. We are saying yes because they have the same measure, 75, and they are in the same circle. So that's why that one gets a yes. Now, question 4 is asking arc AB and arc CD. Now, the reason why I stay away from and I make you focus on this and is for this problem. Arc AB, the measure of arc AB equals 80 degrees. Well, guess what? So does CD. So they're both equal to 80 degrees. That's the measure of the arc, but the arcs are not congruent. You can clearly see that CD is bigger. It is bigger than AB. Therefore, this one is a no, and you get to see why the and is so important. So here is why we say no to this one. Yes, they are the same measure of 80 degrees, but they are not in congruent circles. It's 2 completely different circles. So that's what I need you to focus on with that word and. Moving on to number 5, it's talking about FG and HJ. So first, do they have the same measures? Well, this one measures 90 degrees. This one measures 90 degrees. So it meets the first condition of having the same measure. And they are not in the same circle, but are they in congruent circles? You can clearly see here the radii of both circles are congruent. So this one right here is going to get a yes. They are congruent. And the reason that we are going to give for this one is they have the same measure, 90, 90, and they are in congruent circles. Now the last one, number 6, PQ and SR. So PQ has this angle as well as SR, therefore they do have the same measure and they are in the same circle. So we are going to say yes, congruent, and it's back to what we started with. We have the same measure and the same circle. So that concludes this lesson on 10.2. We have talked about what a major arc is, what a minor arc is, how to measure those, and then what does it mean to be in congruent circles, congruent arcs, as well as the arc addition postulate.